In this video, we discuss another derivation which is based on the centripetal force, circular motion of a car on a banked road. Circular motion of a car on a banked road. Circular motion of a car on a banked road. In the previous video, we derived the result. We discussed about the circular motion of a car on a level road. Now we discuss circular motion of a car on a banked road. So firstly, we understand what is the meaning of banking and what is the banked road. So to raise the outer edge of the road above the inner edge is called banking of road. To raise the outer edge of the road. Outer edge is raised by certain angle. When the outer edge of the road is raised, then the road is called banked road. So the process of raising the outer road, the process of raising the outer edge of a curved road above the inner edge, above the inner edge. The process of raising the outer edge of a curved road above the inner edge is called banking of the curved road. Is called banking of the curved road. So the process of raising the outer edge of a curved road. The process of raising the outer edge of a curved road above the inner edge is called banking of the curved road. And the angle through which the outer edge of the curved road is raised, the angle by which the outer edge of the curved road, the angle by which the outer edge of the curved road is raised above the inner edge. The angle by which the outer edge of the curved road is raised above the inner edge is called angle of banking. Is called angle of banking. This is the definition of banking of a road and the angle of banking. So the process of raising the outer edge, the process of raising the outer edge of a curved road above the inner edge is called banking of the curved road, and the angle by which the outer edge of the curved road, the angle by which the outer edge of the curved road is raised is called angle of banking. Suppose this is the inner edge of the curved road and this is the outer edge of the curved road, which is raised by certain angle. Outer edge is raised by, outer edge of the curved road is raised by certain angle theta. Outer edge of the road is raised by certain angle theta, and there is a motion of car on a banked road. So the weight of the car is acting in vertically downward direction, and normal reaction, weight of the car is acting in downward direction, and normal reaction acting perpendicular to the surface. R is the normal reaction. R is the normal reaction perpendicular to the surface of the car acting at 90 degree to the surface of the car, and force of friction acts towards the center of the curved path F. F is the force of friction, and if this angle is theta, then this angle will also be theta. So there must be two components of R. One is vertical component, which is R cos theta, and the another is horizontal component, and that is R sin theta. And the force of friction also inclined at an angle of theta. This is the direction of force of friction. The direction of force of friction F, which is also inclined at an angle theta. If this angle is theta, then this line is parallel to the horizontal plane, then this will also be theta. And there must be two components of force of friction. The horizontal component is F cos theta, and the vertical component in downward direction F sin theta. So the force of friction is also inclined at an angle theta with the horizontal. Therefore, it must be two components, horizontal component F cos theta and vertical component F sin theta. Weight of the car acting vertically downward R is the normal direction perpendicular to the surface, and this R is making an angle theta. Therefore, R has two components: vertical component R cos theta and horizontal component R sin theta. And force of friction also have two components, one in horizontal direction, and that is F cos theta, another in vertical direction, which is F sin theta. Now we resolve all the forces acting on the car. So R sin theta, the horizontal force acting on the car, R sin theta, and another horizontal force, F cos theta, the horizontal component of force of friction. Both have the same direction, R sin theta and F cos theta. And these two forces is balanced by centripetal force. These two forces balanced by centripetal force. So R sin theta plus F cos theta is equals to centripetal force mv square by R. R sin theta plus F cos theta is equals to centripetal force mv square by R. Now the vertical force mg acting downward direction and the vertical component of force of friction F sin theta. This is also acting in downward direction. So both have the same direction. And in a direction opposite to these two forces, there is R cos theta. So F sin theta plus mg, F sin theta plus mg is equals to R cos theta. And we eliminate the value of mg. So F sin theta minus R cos theta is equals to we eliminate mg. So R cos theta minus F sin theta is equals to mg. This is the second number equation. Now divide first by second. Divide first by second. So we get R sin theta plus F cos theta divided by R cos theta and minus F sin theta equals to mv square by R and upon mg. So 1 times m gets cancelled and we get R sin theta plus F cos theta upon R cos theta minus F sin theta equals to V square upon Rg. So we resolve the forces. The horizontal force F sin theta, the horizontal force R sin theta and F cos theta. So R sin theta plus F cos theta, and both the forces at the same direction, so they will be added, R sin theta plus F cos theta, and these two forces is balanced by centripetal force, and centripetal force is equals to mv square by R. Then the vertical force acting F sin theta plus mg in the same direction, and in opposite direction the force normal direction, the component of normal direction is R cos theta, and we eliminate the value of mg. So R cos theta minus F sin theta equals to mg. This is the second number equation. Now divide the equation first by second. So R sin theta plus F cos theta upon r cos theta minus f sin theta is equals to v square upon rg. Now divide by r cos theta. Divide numerator and denominator by r cos theta. So r sin theta divided by r cos theta. R sin theta divided by r cos theta plus f cos theta divided by r cos theta upon r cos theta divided by r cos theta and minus f sin theta divided by r cos theta equals to v square upon rg. We divide the numerator and denominator by r cos theta. So we get r and r gets cancelled. So sin theta by cos theta. Here cos theta cancelled. So r sin theta by cos theta. This is tan theta plus f by r. Tan theta plus f by r. F is the force of friction. And here r cos theta gets cancelled. 1 minus f by r and sin theta by cos theta. This is tan theta equals to v square upon rg. And we know f by r equals to mu, coefficient of friction. So tan theta plus mu upon 1 minus mu tan theta equals to v square upon rg. And we find the value of v square. So v square equals to rg into mu plus tan theta. Rg into mu plus tan theta upon 1 minus mu tan theta. And v equals to under root of r into g and mu plus tan theta upon 1 minus mu tan theta. This is the value of speed of the car, velocity of the car. V equals to under root rg mu plus tan theta upon 1 minus mu tan theta. So this is the expression for maximum velocity of the car on a banked road, circular banked road. Now we discuss the cases. The first case is when there is no friction between the road and tires. Case first. When there is no friction between the road and tires. The first case is we are taking that if there is no any friction between the road and tires, then in that case mu equals to 0 and the value of v is under root of r into g. This mu becomes 0 and this mu also 0, so only remains tan theta, rg tan theta. V equals to under root of rg tan theta. This is the speed of the car when there is no any force of friction. So this is the safe limit for maximum speed. This is called safe limit for maximum speed of car. Safe limit for maximum speed of car V equals to under root of Rg tan theta, and the angle of banking theta is also calculated by from equation number 3. From equation number 3, the value of angle theta, known it from equation number, name it third number equation. From equation number 3, so V equals to squaring both sides. So V square equals to Rg tan theta, and tan theta equals to V square upon Rg, and the value of theta is tan inverse V square upon Rg. This is the formula for finding the angle of banking. This is the formula for finding the angle of banking, at which angle the outer edge is raised above the inner edge for the safe limit of speed. Theta equals to tan inverse V square upon Rg, angle of banking. So let us see once again the definition of banking of a road is the process of raising the outer edge of a curved road. The process of raising the outer edge of a curved road above the inner edge is called banking of the curved road. And the angle by which the outer edge of the curved road is raised, the angle by which the outer edge of the curved road is raised is called angle of banking. So the motion, there is a motion of the car on a curved banked road. The outer edge is raised by an angle theta. Weight of the car is acting downward. Normal direction is perpendicular to the surface of the car. And if this angle is theta, then this angle will also become theta. There must be two components of R cos theta and R sin theta. This is the force of friction acting downward direction. So the force of friction F, this is the direction of force of friction, which is also making an angle theta with the horizontal, because this is parallel to this. So alternate angle must be equal. So there must be two components of force of friction F, horizontal component F cos theta and vertical component F sin theta. Now we resolve the horizontal force R sin theta plus F cos theta, and these two forces must be equal to the required necessary centripetal force, which is mv square by R, and the total upward force R cos theta, total downward force mg plus F sin theta equals to total upward force R cos theta, and we eliminate the value of mg. Now divide first by second. We get the expression R sin theta plus F cos theta upon R cos theta minus F sin theta equals to V square by Rg. Now divide the numerator and denominator of each term by R cos theta. So R sin theta by R cos theta, we get tan theta, and F by R cos theta gets cancelled, and for F by R comes R cos theta by R cos theta 1 minus F by R cos theta. So F by R sin by cos tan theta equals to V square by Rg. And F by R can be written as mu, coefficient of friction. So tan theta plus mu upon 1 minus mu tan theta equals to V square by Rg. And we eliminate the value of V square equals to Rg into mu plus tan theta upon 1 minus mu tan theta. And the value of V in a square root Rg mu plus tan theta upon 1 minus mu tan theta. Now we have taken the case when there is no friction between the road and the tires, means mu equals to 0. So when we put the value of mu equals to 0, we get the safe limit for maximum speed, V equals to under root of Rg tan theta. And for finding the angle of banking, we squared both sides, so V square equals to Rg tan theta, and the value of tan theta is eliminated, and theta equals to tan inverse V square upon Rg.